So 6.4 part 2, starting off, the rate of the number of bighorn sheep in a population increases at a rate that is proportional to the number of sheep present. So this is actually a description of an exponential function. Any population, any radioactive material, interest-bearing money is usually modeled by an exponential equation. And most of you are familiar with, and this is, by the way, coming straight out of your 6.4 packets, so it should look familiar. That is the one that you're probably the most familiar with, but the way that we deal with it as a differential equation. And how do I know that? Because of these words, the rate of change. I'm using time because that's going to be our independent variable. Is proportional to means multiplied by k. The amount present would have been the y value itself. So we're actually going to take that and we are going to solve the differential equation. And so here, I'm going to solve this guy, which you should be familiar with from the last video, the part 1. So I'm going to divide by y, and I'm going to multiply by dt. Take the integral of both sides. The left side, the integral of dy over y, is the ln of y. The other side, this is a constant. It's the constant of proportionality. Therefore, it is not a variable, so please do not raise it to a power and then divide by the power. The variable is t. So, add your plus c. Now I'm going to raise both sides to the e. When I do that, I am going to cancel my ln. I get the absolute value of y is equal to e to the kt. And I'm going to split this up right now. E to the c. Y is equal to the plus or minus e to the kt. Remember, absolute value is canceled by a plus or minus. And then I'm going to highlight my plus or minus e to the c. I am going to make that an a value. And we end up with this. Y is equal to a e to the kt, which, if you remember a second ago, remember I wrote pert? Same exact thing. The constant of proportionality happens to be the rate of increase or decrease. So, given that, this is an initial amount. You just heard me say what k was. K is your rate of increase or decrease. So I gave you, I believe, some multiple choice questions inside of the packet, and we're going to take a look at those when I actually find them. There they are. The number of bacteria in a culture is growing at a rate of 3,000 e to the 2t over 5 per unit of time. So the rate is equal to 3,000 e to the 2t over 5. At time equal to 0, the initial amount was, so this is time, this is my initial amount. Find the number present at t equal to 5. So let's hope that I do this correctly. I am going to first start off by separating. There's really nothing to separate. Dy is equal to 3,000 e to the 2t over 5 dt. Integral, this side is y. The other side, the 3,000 stays. E to the 2t divided by 5 divided by 2/5. The dn is 2t. Sorry, the dn is 2/5, so I'm going to divide by 2/5, which is multiply by 5/2. So that is the antiderivative with a plus c. I'm going to put in my initial value, which says that 7,500 is equal to equals, so 5 times 1,500, 7,500 e to the 0 plus c. Hopefully you notice that c ends up equaling 0. So our actual equation, which I'll come over to the left, y is equal to 7,500 e to the 2t over 5. And then I want to find the amount present at time equal to 5. That would be 7,500 e to the 2t divided by 5. That should just leave me e squared. So the answer to this one, hopefully, is C, if I did that correctly. Next problem. Bacteria in a certain culture increases at a rate proportional to the amount present. All right, so let's start with that. The amount present, so that would be KY. So that kind of goes back to what we just did a second ago. If the number of bacteria doubles in 3 hours, so time equal to 3, the initial amount doubles. Okay, so let's start off with, first, I don't know what the equation is. In how many hours will the amount of bacteria triple? So let's see. Let's start off with this guy. So K is your constant, remember. So I get the ln of y is equal to KT plus your C, absolute value around the y. Use my E to cancel, and I get the absolute value of y is equal to E to the KT times E to the C. Y is equal to plus or minus with the EC. I'm going to write just A, so I'm skipping a step there. Let's see. So this is my initial amount. Remember I said that? Then if it's going to double, then my ending amount would be double that, 2A. My formula again, A, E to the K, and it took 3 hours to do that. So that is enough information to find K. So watch what happens when I divide by A. I'm left with 2 is equal to E to the 3K. Therefore, the E is isolated, the base is isolated, so I can take the ln of both sides. The ln of E, with this power, I'm going to bring that in front, so I'm going to show every single step. 3K times the ln of E. Remember the ln of E is the same thing as 1. So I get that K is equal to ln of 2 over 3. And that's only part of the work. Now they want to know in how many hours will the number of bacteria triple. So I found my K value. I'm going to take my original equation, and let's see if it's possible for me to squeeze the work in this little box here. So my original equation, y is equal to the initial amount times E to the K, ln of 2 over 3 times T. They want to know when the bacteria will triple. So really I want to find 3 of the A is equal to ln of 2 thirds, or sorry, ln of 2, not 2/3, divided by 3, and I'm going to write that a little bit neater. Sorry, this computer is very slow right now. I'm just going to... ln of 2 divided by 3, whole thing multiplied by t. So e to the ln of 2 divided by 3, whole thing multiplied by t. And I'm going to cancel that. So let's find some more space. Let's come into the middle right here. We are going to have 3 is equal to e to the ln of 2 divided by 3 times t. And pretty much we're just solving for t. So we end up with, take the ln of both sides. I get ln of 3 is equal to, and I'm going to squeeze the ln right here so you can see it. The ln of e is going to cancel, and I'm going to be left on the other side with ln of 2 over 3 times t. So my answer for t would be ln of 3 divided by ln of 2, but multiplied by 3. And we have that answer A. A puppy weighs 2.0 pounds at birth and 3.5 pounds 2 months later. If the weight of the puppy during its first 6 months is increasing at a rate proportional to its weight, then how much will the puppy weigh when it is 3 months old? So, at time equal to 0, the weight is 2.0, and 3.5 2 months later. So these are some points on the original function. So the amount that the puppy weighs, so y is pounds, is proportional to its original weight. All right, so if you notice, I'm going to do it again. No memorized equations, please. dy over y is equal to k times dt, which means, yes, you need to do this every single time. I want to see all the steps. I do not want to see you just writing the exponential equation. This would be the ln of absolute value of y is equal to k times t plus c. And we can start shortcutting a few steps. We know that we end up with the absolute value of y is equal to e to the kt, e to the c, and then to get rid of the absolute value, we're going to use the plus or minus, but we also have the e to the c, so I'm going to write a instead. So I want to see this process. I know it's long. There is a reason I make you do it, okay, not just to torture you. So given that, I'm going to put in my initial point, this one here, and that'll help me find one of the values, a. K times t equal to 0, and that's going to cancel to 1, so a is equal to 2. Then I'm going to write my equation over again and use the second point. Second point, the y value, the weight, is 3.5. The a value we found was 2. E to the k I don't know, but I know the time was 2. So here I'm going to be able to find k. So 3.5 divided by 2 is equal to e to the 2k. So here we go. We end up with 2e, it's going to be fun, to the, and I think I'm going to put the 3 in front, 3 ln of 1.75 divided by 2. And there should be 2 sets of parentheses, and hopefully I did that correctly. Enter 4.63. Which would be 4.6 pounds. So letter B. And I think there's one more that is very similar. So if you look at this one, I'm not going to do this one for you, but it is very similar to the one that we just started with. It says that the people infected increases at a rate proportional to, so y over dt, y being the number infected, is equal to k times the amount of people already infected. If 1,000 people are infected when the epidemic is first discovered, so that's 1,000, and 7 days later it's 1,200. Those are the 2 points that you would use to find where time is equal to 12. So this is exactly the same as the problem I just did before. So hopefully this helps you a little bit in understanding. Going back to the problem I did before, you will not receive credit if you skip the steps in the beginning that I used to find the original equation. There is a reason I'm making you do that. I do not want you to just automatically write the exponential equation. So this is a 3-step process for this problem. When you're given 2 values or 2 points on the original curve, you will have to go through a 3-step process. The first step essentially helps you find your a value, the second step helps you find your k value, and then the last step answers the actual question.